Okay, let's get started. You guys can hear me, right? Clearly? Hello? Hello? So I think the last topic that we discussed was about static, right? What is a static variable and what is the instance variable, and what is the difference between these two is what we have discussed in our last topic. Okay. And we've also gone through certain naming conventions that you have to follow and all. How to name your class, how to name your instance variable, those kind of stuff. Okay. Let's continue today. Today we'll discuss the next topic. Basically, we'll discuss how OOPS is implemented in Java. Right? We all know what is OOPS. So today let's start about how we use OOPS in a program. Okay. So who can explain what is an encapsulation? When I say an encapsulation, what is encapsulation? So we have two answers. And again, as I said, I want this to be very, very interactive. Right? This will ensure you build your communication skills, and also it will help you in recollecting stuff. Okay. So encapsulation, again, I'll try to reiterate what I mentioned earlier. Encapsulate is to protect something, just like encapsulate, in a just like how medicine is protected in a capsule. Encapsulation is all about protecting data. So encapsulate is to protect. And in a programming world, what we are going to protect, as I said, OOPS is all about how you organize your data, right? So encapsulation is all about how to protect data. Okay. So a classic example is, let's say you have a bank account, right? So what is the most sensitive data to protect in a bank account? What is the most sensitive data to protect in a bank account? So the first thing is balance, right? It's okay to, even if you leak information, your email ID, your name and all, but the most important information is balance. If let's say, I'll show you an example, okay? Let's see an example, then probably you will understand better. So I think I should have, 1 second. So should I have a class called bank account? Okay, so to make things simple, I have a bank account in which I'm accepting name, account number, and balance. Okay, and we have constructor overloading. We discussed what is overloading, right? Something which is in abundance. So here I have a constructor overloading. I have a constructor bank account which is accepting name and account number, and another bank account which is accepting balance additionally. Okay, so there that is there. Okay, now let's do one thing. Let me create a new class called bank account test. Okay, so I created a new class called bank account test. Now in that, let me create a main method. So we have a main method here. Now let's try to create bank account object. Let's say I create a bank account. Account 1 is equal to new bank account. Okay. Now what are the details that I need to provide to the bank account? I have to provide the name, account number. Okay, so let's say we're creating an account for Tom, and the account number is, let's say, 1234. Okay, and just for the sake of example, let's be there. Okay, now you are able to create a bank account object with all the relevant details. Let's go ahead and add some balance. So I will say account 1 dot. Let me do one thing. I'll make this as public. So far we have been using public. So I'll make this as balance as public. Now balance is equal to, let's say, $100. Okay. So far so simple, right? Now let me print let's print the details. Okay. Details. I'll say name. I'll say ACCT1 dot name. Okay. Plus balance. Dot balance. Okay. So when I run this program, it should print the name and it should print the balance. So it's just $100. Okay. So balance is $100. Okay. Now let's do one thing. Let's say we want to deposit. We want to deposit, let's say, $50. I want to deposit $50. So I'll say ACCT1 dot balance is equal to ACCT dot balance plus, okay, let's say I'll put a thing int amount to deposit. If you can see, let's say I'll give you an example. Just 1 second. If you can see here, I'm following the naming conventions that we talked about. The field name should follow camel case, and the first letter should be in lowercase. Amount is lowercase. Then 2 is a different word, so I started with a capital letter. Then deposit. Deposit is a different word, so I started with a capital letter, right? So make sure you follow this naming conventions. It should not be something like this. So it should not be like this. This is a bad practice. So you always need to follow camel case. Okay. So here I want to deposit $50. Okay, very good. Now when I deposit this and when I print, what should be my updated balance? What should be my final balance? Anyone? Any guess? It is simple math there. Is it 150 or is it 50? What is the answer? How much is 100 plus 50? 100 plus minus 50. Let's see. Let me run this program. So if you see, here we said plus amount to deposit, right? So ideally it is 100 plus 50. So the amount should be 150. But why is it 50? Right, it's simple. It is 50 because some guy accidentally put a negative number here. Instead of plus 50, He entered -50, right? So now assume what will happen if such a mistake is done by programmers. Or let's assume, you go to ATM and you just deposit, or you go online and you kind of are able to manipulate your balance. You're saying that you are depositing +50, but you're actually depositing wrong value, right? So if you see here, the data is not safe. People are able to access the data and they're able to manipulate the balance, right? Like another example is, let's say I want to withdraw. I want to withdraw 100. Now let's see. Dot balance is equal to account1 dot balance. Since we are withdrawing, we should say minus, right? So I want to minus $100. So we subtracted $100. Now what should be the end balance amount? It should be -50, because 100 and you're subtracting 50 out of that, so it is 50, and then you're subtracting 100 out of the 50. So your balance went to negative, right? Now this is a test program. Now if you do such a mistakes in a real world, you can think how big a mistake it is. Now how costly it will be to that particular client. Do you guys agree with me that this is a danger, there is a risk here? See, you're not protected your balance here. Someone was able to go ahead and deduct $100 to that, right? Let's say a programmer like me, what they can do, they can just go and say, you know what, let me change my balance to right. I was able to hack this. I was able to create my objects. Now if you see, my balance is good number there, right? So encapsulation is all about, 1 second guys, just give me 1 second. Yeah, sorry about that. Okay, so yeah, so if you don't protect your data, right, you can see the risk of it. That's where one of the core features of OOPS comes into action, which is something called encapsulation. So encapsulation tells you what are the different ways to protect your data, right? So let me make some few changes here, okay? Then we will see how to use encapsulation. First and foremost is, so far we have been using public, right? We have named everything as public. So what is the opposite of public? Forget about Java. In a real world, what is the opposite of, what is the antonym of public? Right? So the opposite of public is as simple as it is. It is private, right? Public function and a private function, as simple as it is. So Java also has something called private. So I'll mark this as, instead of public, I'll mark this as private. Okay. So there's a new thing that we are seeing. If you don't want your instance variable or method to be accessed outside this class, right? In such scenarios, you will be using private. Okay, so when you mark something as private, when you mark something as private, that particular variable or the method is not visible outside the class. Okay, what I mean by that is, see here, I changed this to private, and 1 second. The moment I change that to private, if you see here, I'm getting compilation errors. Right, it says the variable balance is not visible. The field bank account balance is not visible. Okay, now let's try to fix this. So our intention was to, just give me 1 second guys, my system is kind of busy. Okay, it should back. Okay, so the intention here, so let's discuss what is the use case here. The use case here is we want to use balance for 3 things, right? We want to first read balance, right? We want to know what is the current balance. Second thing is we want to deposit. We want to deposit amount. Third thing is we want to, what is the opposite of deposit is to withdraw, right? These are the 3 operations that you want to perform on this balance. Other than this, you should not allow any other operation, right? So let's provide methods for this particular 3 operations. And as we all know, implementing an operation in Java is to write a method. Okay, first and foremost is let's provide a method to get the current balance. So we'll say a public, and since we are returning the balance is of type something called double. Double is used to indicate decimal values, right? You all know what is a decimal, right? Something like 10.5. Anything with accepting decimal values in Java you'll use double. If you use int, it will accept only non-decimal values. It will not accept any decimal values. So just for the sake of example, here we are using double. So I'm saying I want to have a method public called public double, and I'll say get latest balance. And here I want to return this dot balance. Okay. So whoever wants to access the balance, they should call the get latest balance. Now, do you think this is kind of an encapsulation? If you see here, we disabled access to the balance. Now, whoever wants to access the balance, they should call the get latest balance method, right? So thereby we are protecting the read operation. Okay. So let me change the program. I'll change my program which was failing earlier to use this method. So wherever you want to display the balance, you need to call the get balance method. So here we are displaying the method, here we are displaying the method, so the balance. So here we all want to get the balance. Okay. Now the next thing is we want to deposit amount. Okay. So public, let's say void deposit amount. Okay. Now we want to say double amount to deposit. Now if you see, take a look at my naming convention here. Deposit is a different word, amount is a different word. We are using camel case, and class names start with lowercase, and every word after that starts with an uppercase. Okay. So since we are depositing amount, I will say this dot balance is equal to this dot balance plus amount to deposit. Right. Let me copy paste this, and let me provide say withdraw. assuming withdraw is a simple, is a unique, is the same word, amount to withdraw. So we have a typo here, amount, and amount to withdraw. Now here I have to use the negative operator, right? Clean. So any questions in this particular class? Is this straightforward? Is this simple? Does everyone understand these three methods here? So here we provided methods to read balance, right? And here we provided the method to deposit balance. Now the third thing is provided method to withdraw amount. Okay, so three options. Now let's change the program which is want to deposit. So here initially we are saying we want the balance to be 100. So for that we provided a constructor. So I'll change, and here I'm saying I want to create an account with balance $100. Okay. After that, if you want to deposit amount, so here I want to deposit. So instead of calling this, I need to say account one dot deposit amount, and here I'll say amount to deposit. Okay. And here we want to withdraw. So account one dot, I will say withdraw. You want to withdraw $100. Okay. And see, if you see here, this particular operation is not possible anymore. I cannot directly go ahead and manipulate my balance. I either have to use a deposit amount or a withdraw amount. Okay. So let me do one thing. Let me comment this for now. Okay. Now when I run this program, I expect to see a valid output. When I say valid output, what I mean that we have written methods. We have written methods to protect our balance, right? But here if you see, it should not allow to deposit negative balance, right? That's not a good practice. End of the day, you have written methods, but you're not getting the expected output, right? You're not protecting your data. Okay. Now let's do one thing. Let's update our program and add some safe checks. So I'm saying if amount to deposit is greater than 0, right? We'll discuss about these if conditions later, but just try to follow this example. Okay. So here I'm saying if my amount to deposit, right, if the amount that you're trying to deposit is greater than 0, the simple math, then perform the deposit. Else, for all other cases, print out a message. Invalid amount entered. Please enter a valid amount. Right, so it will print out a message. So let's run this program and see now. So if you see here, it says invalid amount entered. Please enter a valid amount. And my balance is still correct. In this case, my balance is correct. If I don't protect my data, right, if I don't implement this condition, I'm getting an invalid balance here. I was getting -50. Right. Likewise, let's try to do the same thing for withdraw. Right. Currently, let's say my balance is 100. If I go ahead and withdraw $300, it will allow. My balance went to negative, so we should prevent that. Right. So I'll put such kind of a check here. If what should be my condition here? Who can help me out writing the condition here? What should be the condition to check before while you're withdrawing the balance? Right? It's a real world situation. If you go to an ATM and you try to withdraw the amount, what is the first thing that it should check? Provided you you've given valid user ID and password. So it should be very good. Should be amount to withdraw should be greater than, actually other way around. This dot balance should be greater than amount to withdraw, right? Balance amount should be greater than what you're trying to withdraw. For those who gave me this particular amount to withdraw greater than balance, that's wrong, right? The balance that you want to withdraw should be greater than amount that you're trying to withdraw, right? So else we print a detailed message: insufficient funds to withdraw. Right, so now if we go and run the program, see here, at any point of time, if you are giving wrong input, the program is not allowing you. The program is safeguarding your data, right? I cannot, let's say I try to go and deposit -100. Let's see what happens. If you see here, again, it went to an bug. I tried to withdraw negative amount. So here it created wrong input. So here we have to change the condition. So we'll discuss about what I'm doing later on, but you understand, right? Withdraw should be greater than 0. So I'm putting an extra condition there. Now when I run this program, I'll get a valid balance there. So you can ignore what I wrote inside this program, but you understand the concept, right? How we are safeguarding our data, how we are protecting our data from invalid access. If you can see, this is your bank account, right, wherein you have your information stored in an object. Now any program, right, any program who is running inside the JVM can create bank account objects. Right, now if they get access to your object, they can manipulate the deposit. They can manipulate sensitive information. So you need to really safeguard your object, right? So that is what is known as encapsulation, how to protect your data, right? So this is how you protect your data in Java, by using the right, this is called access modifier. Right, if it's sensitive data and it should not be shared outside the class, you mark it as private. And then you provide methods to manipulate the data, whereby you have control. Right? Is that clear? What is encapsulation about? I'll take a minute break here to answer any questions. Remember, this is a very, very core concept, right? Fundamental. This is like ABCs of OOPS. So make sure you understand this concept very, very clearly. Please feel free to ask me any questions. Okay, no questions. Very good. So I'm assuming everyone understood. I have a question. Now, can you explain? Can you think about some other real-world situations where you'll be using encapsulation? What do you think there are real-world situations where you'll be using this kind of feature? Please unmute and speak. It's faster than chatting. So we have an answer. One answer is government organizations. Remember, we're talking about objects, classes, and all. So give me examples in that, not in hospitals and all, but just give me some scenario. Like for example, in my let's say my phone, right? My phone, if it's a prepaid connection, sensitive data is the account balance in that, and I need to protect my balance, right? Now think about, let's say, your car. What is the sensitive information in car which should encapsulate? Think about, object, anything like a student, right? In a student object, what is information that needs to be guarded? So in student, we have grades. Okay, very good. What about them? What about others? That's it. Let's say you're supposed to design an application for your wallet, right? We are creating a digital wallet. So what information you need to protect in your wallet? Come on, you guys need to think, right? Programming is all about how will you visualize to model a real world concept. Let's say you're given a requirement to model a digital wallet. So what does a wallet contain? A wallet contains your information like credit cards, cash, your visiting cards, right? All sorts of things. ATM pins, very good. We need to protect all those things, right? So you will, let's say, design a wallet class, right? In that you will make sure the data is protected using encapsulation. Okay, very good. Any questions on encapsulation, where it is used, why it is used, or how it is used? Okay, good. So let's move on. Let's move on to the next topic, which is known as inheritance. Okay, so who can explain what is inheritance? What is inheritance in OOPS? When I say inheritance, what does that mean? So, as the name says, inherit. Inheritance is to inherit. And we all know what inherit means, right? A child inherits from parent. Okay, this is one example. Another example is, let's say, iPhone. What is the difference between iPhone 6 and iPhone 6 Plus? 6S or 6S? I don't know. I get confused. iPhone 6S and 6S Plus. What is the difference between these two? Right. So let me just Let me go get those names correct. So I'm going to the Apple website, and let's say you want to go to an iPhone. Okay, that's iPhone 6, right? So they have two models here. Let's see. Come on. So they have iPhone 6 and iPhone 6s or 6 Plus. Okay, some name. So iPhone 6 and iPhone 6 Plus, right? Now, can I say iPhone 6 Plus inherits from iPhone 6? Can I say that? Think about that. When you inherit something, you get all the features, and in addition to that, you have some extra features, right? iPhone 6 Plus has all the features of iPhone 6. In addition to that, it has some advanced features, and one of the advanced features is screen size. Okay, does everyone agree with me? That is inheritance in our real world. Now let's assume you're asked to design a class which represents iPhone 6 Plus and a class which represents iPhone 6, right? So in Java, let's create a sample class here. So I'll say class iPhone 6 something. Now I'll create another class called iPhone 6 Plus. Okay, so these are two different classes. Now, how do we implement inheritance? Right, so the way to implement inheritance in Java is to use something called extends. The word extends, and here you specify the class that you are inheriting from. The word extends is indicating that iPhone 6 Plus is inheriting all the features from iPhone 6, right? So the word extends is a keyword. Just like class, the word extends is a reserved word. It's a reserved word in Java. And by using extends, you specify that a class is extending another class. Okay, so what this means is iPhone 6 is inheriting all the iPhone 6 Plus is inheriting all the features of iPhone 6, right? So in that case, there are some new words here, something called superclass. So iPhone 6 is the superclass, and the class which is inheriting is known as subclass. In this case, it is iPhone 6 Plus. Okay, so going forward, whenever we are talking inheritance, we will use the word superclass and subclass. Superclass is used to indicate the parent, and a subclass is used to indicate the child, right? And at any point of time, a class can extend from only one class, right? You cannot extend from more than one class in Java. Okay, that is known as single inheritance. This is known as single inheritance, wherein a class is inheriting from only one other class. Java does not support something called multi-inheritance. It only supports single inheritance. At any point of time, a class can extend from only one other class. Okay, any questions here so far? Okay, very good. Now, before going into coding, let's try to see what other real-world examples can we think about where inheritance is used. Okay, I'll give you another example. We have cars, right? And there are many submodels in a class. Let's say, I'll say, let's pick something called like a Toyota Corolla. Right, let me just go right here and say Toyota Corolla. And I'll just search for some model names here. Just 1 second. So Toyota Corolla has how many variants? They call it as variants. So only if they can decide can load. Just 1 second. Okay. So if you see here, they have different models here called L, LE, LE Echo, and S. Okay. But let me just say Toyota Corolla. I'll say L. Okay. And let's say then we have Toyota Corolla E. Let me say I'll just put underscore here so that it's clear for us. LE. And then for the namesake, let's create another called S. Okay, so this is the least model, right? And then on top of that you have LE. So LE has all the features of L plus some additional features. And then you have something called S, which has all the models of L, all the models of LE, and some additional features, right? So this is inheritance. Do you guys agree with me? What we are seeing is that inheritance or not? No? You guys don't agree with me? Hello? Are you guys with me or not? Okay, very good. So, right, now let's continue. So let's try to model this. Let's try to model this in a program. So here we have class Toyota Corolla L. Okay, now we have to build a class called LE. And so LE inherits from L. So that means LE extends from LE, right? So the LE version inherits all the features from L. Now S. So S needs to inherit from LE and L. So this is the grandparent, this is the parent, this is child. Okay. Now let's try to model that here. So I'll just copy paste it here. Remember, we said Java is single inheritance. So at any point of time, it can inherit from only one class. Right? So that means the S should inherit from LE. And LE inherit from L. Right? So here we have a chain. Now S is inheriting from all the features of LE, and LE is inheriting all the features of L. Right? So this is how you implement inheritance in Java. Is that clear, everyone? And if you see, these are all real world examples here. These are not, some sample dummy examples here. Now, can you give me some examples where you think you'll be using inheritance? It doesn't have to be complex, simple, just very, very simple. No one? You don't want to try at all? Okay. I can give like any number of examples, right? Let's say jeans. If you go to Levi's, they have these different numbers: 501, 513, 514. If you can see, these are all nothing but jeans. Jeans which are slight different from another model. You know, they have a slim version, they have a straight cut. If you see, these are all one model differs from another type of a model. Right, so you can say that 514 is inheriting from 513. The only difference is in the bottom, the width is slight larger, right? That's one example. Now, if let's say if you go to Starbucks, you have a plain coffee, and then you have coffee with some, let's say, chocolate, right? So plain coffee can be your super class, and then let's say mocha. Mocha will be your coffee plus some additional features, chocolate, right? These are all real world examples where you can see some other thing is inheriting from a parent, right? It need not be something like a physical object, but if you look around, anything, that's the beauty of object oriented programming. You can model anything as a program because everything is an object, right? An object has data associated with that. So you can take any example and start implementing inheritance with that. So can you tell me in this particular the line that I have highlighted, which is the superclass and which is the subclass? Which is the superclass and which is the subclass? You don't have to type everything. Just type after underscore, right? Which is the superclass and which is the subclass? Okay, very good. What about line number 41? Which is the superclass and which is the subclass? Very good, very good. Right. So good job there. Let's I think before we start working on some examples, let's stop for today. I want you guys to implement one example of encapsulation, a real world example, not what I said. You can repeat this particular thing for your practice. Implement the bank account example. Apart from the bank account, I want you guys to implement another real world example. So think about that. We discussed many examples: student, wallet, mobile phone, right? Think around and try to implement a real world example for encapsulation. Similarly, I want you to implement this particular concept in Java. Go ahead and create these classes, okay? And also think about some other real world examples where you think inheritance is actually being used, okay? Let's stop for today. Tomorrow we will proceed with writing examples in inheritance, okay? Any questions there?
Hello?
Yeah.
Hello?
Yeah, I can hear you.
Like we are getting balance from get balance also, means like how it is protected from the external ones.
You're getting the balance, but are you able to change the balance?
But you read by reading also. It's difficult to if you use a get balance, but we are reading the balance from the superclass.
Reading the balance from the superclass. Here we are not using inheritance anyway.
Not the superclass. Sorry, no, not the superclass. But we are reading the balance from it. Like, can we read from get balance?
See, the important thing is you should not be able to manipulate the data. That's the important thing. You should be able to protect the data.
Okay.
Right? So if you don't want to read the balance, then what I will do, I will go ahead and make this method as private.
Okay. Thank you.
So the moment I make it as private, if you see, no one has access to the get balance method there.
Okay.
So the important thing is you need to decide how you want to protect the data. So here we are making sure that they cannot write the data, right? For example, if you're using the USB, right? Some USBs have lock option. If you lock it, users can only read the data. They cannot write to that USB, right?
Okay.
So something like that. The important thing is you need to decide whether you need to provide the data as read only, or you should not provide the data at all. So it's all the power in the program and the programmer.
Okay, thank you, sir.
Okay. Any other question? Anyone? And Siddharth, you don't have to wait until end of the class. You can, if you have any question, just stop me immediately and ask me. Please do not wait until we finish the class.
Okay, sir.
Okay.
Okay, sir. Thank you.
Yeah. Okay, fine then everyone. Let's continue tomorrow. Okay, I'll upload the recording, but please make sure you implement the examples and the exercise. Okay. Thank you everyone. Bye.